I will hand it over to Scott Collis next to talk about the ARM translators and open science.
Thank you so much, Adam. Let me see. I'm on Teams, so this is not necessarily guaranteed to work, but are you guys able to see my screen?
Now we can, yes.
Excellent. I'm going to put this into slideshow mode. And are you able to see my slide?
Yep, that looks good.
Wonderful. So thank you so much for having me here today, Adam, and greetings to everybody at home. I'm going to add my excitement to Adam and Jim's and say I'm, kind of being an early adopter of some of these philosophies. It's heartwarming just to see the popularity and the acknowledgement that open science is better science in our community, and just seeing the number of you who have come along and giving up some of your free time to hear about the open source efforts in ARM and of our stakeholders. So my name is Scott Collis. I'm an atmospheric scientist at Argonne National Laboratory. I am also one of what we call an ARM translator. And I'm here representing the rest of the translator group, which includes Jennifer, Scott, Damao, Xiaoxing, John, and Krista, to talk about open science in the ARM translators, past, present, and future. So Jim referred briefly to the translators in his opening remarks. The translators fill a very respected in the community, and especially from other agencies. We often have commented from other agencies how much they think they need a role like a translator in their programs, because the role of a translator is really to act as a liaison between the scientific community and ARM infrastructure staff members. Our role is to maximize the scientific impact of ARM measurements, and we do this through a variety of mechanisms. One of the main mechanisms is the development of what we call value-added products, bringing in well-known retrievals and other codes from the literature and applying them to ARM measurements to make them more impactful. We also act as direct points of contact and help where needed throughout the facility and the community. And here you can see the translators and their various roles. Xiaoxing leading up our modeling, and he's a modeling point of contact. And I'll get to the different AMF point of contacts later. John, who leads the work in aerosols. Damao in high latitude value-added products. Myself as a point of contact for convective clouds, deep convective clouds. Scott, who is our lead translator at the moment, and he's in charge of the warm clouds point of contact. Jennifer, who acts as overall leadership for us as the engineering and process manager within ARM. Krista, who leads soft development, and Ken with data quality, who really acts as our point of contact within the data quality office. So the translators and open science. We've been doing open science since before it was cool, because all of the products that the translators produce, the value-added products, they're open data, and they are designed to be accessible by everybody. There is no insider game here. There is no secret sauce. However, VAPs were historically developed using coding languages, which made it more efficient for the PI to transfer. There has been a shift recently into open source Python-based value-added products, spearheaded by the Python ARM Radar toolkit. And I'm not going to take away from Max Grover's thunder, because he's going to go into more on open radar science in general. But this top figure here shows the growth of contributors in the Python ARM Radar toolkit. The light blue are internal contributors, those who are funded by the ARM program, and the blue are the external contributors. The ARM translators make heavy use of open source software, and a really great example of this is the LD Quants VAP, which uses the PyDSD open source code base developed by Joe Harden, who was previously at PNNL and is now in Climate AI, I believe. And that is actually used directly in the LD Quants product, which takes the DSD information from the laser distrometer and calculates radar moments from that reflectivity, differential reflectivity, as well as the companion value-added product, which is the 2D video distrometer forward moments of reflectivity and so forth. The other area we've been working in open source is in the ARM data integrator. This is a key code base used within ARM for connecting ARM's value-added products to various databases and so forth throughout the program, including the PCM and the data object definition. And we've released that as open source so that the community is able to use on it and build on it as well. So that was in the past. Looking forward, we're currently going through an exercise right now. Jim referred to ARM's decadal vision and the other planning documents that are there. So the translators are putting together coordinated vision for fiscal year 2023 through 2025, and that will be very much aligned with other planning activities within the ARM program. In this strategic plan, we're acknowledging the need to pivot towards open science activities. We also acknowledge for this transition to be feasible, it requires resource allocation and reprioritization. Accessible open science isn't just putting code and other materials online, but some activities that are being suggested in our planning document is one of them is the idea of companion notebooks. Anytime we come up with a new value-added product, and Adam referred to this briefly, the idea of cookbooks, we should make available cookbooks that show how to use these VAPs, how to work with them as a type of ARM data, and also some information in these notebooks that show how the assumptions and so forth that go into this. This, by the way, will dovetail with many other efforts within the program, including data epics as well, because we can show, data epics are a definition in date and location and instrument class of key data sets that might be particularly good in terms of their calibration, or when an impactful event happened. A key example recently being the eruption in Tonga, where our measurements were able to actually pick up the pressure wave that came around. So by using these data epics and value-added products and cookbooks, we'll be able to highlight key data sets. Another suggested activity is engineering and re-engineering of many of our most valued value-added products to make them open. And one thing I can not necessarily announce, but advertise here, is Python is now the recommended programming language for value-added products in the translator group. Basically, the translator teams would need to have a very special reason why not to implement something in Python as a programming language that really enables open science across the atmospheric sciences. So just by doing these things in Python to begin with, we make them more accessible. When new value-added products are proposed, their open available nature will be very much taken into consideration. It's kind of shorthand for saying there need to be a very good reason why a VAP shouldn't be done in an open nature. High impact value-added products, with the key example of being the actively remotely sensed cloud layer product from Scott Giangrande's team, are ones that we will specifically consider for re-engineering and making open source. And I've been told by Scott that there's very much already efforts at Brookhaven into open sourcing RSchool and re-engineering into those frameworks. The other area that the translators have been very active in kind of a meta sense, because it doesn't actually necessarily produce code or data products, is in open accessible science. As I kind of said before, we can put all of our data online, but unless it's easily accessible by users with a wide background of knowledge in the ARM program, it's not going to have much of an impact. So, two areas of translators are contributing in this area, are working with the ARM Data Center on things like recommended data stream and improving descriptions of the data we've got there, such as the one pages. And this might be an area where the cookbooks, these open notebooks fit in, as in our one pages can now actually have a dynamic executable component that will actually allow users to become quickly spun up on a VAP. We've also been adding points of contact for AMF deployments, and that was referred to in that translator slide before, to kind of help to demystify the facility to users and PIs who might not have that much knowledge of it. Going forward, we'll be looking for additional ways to engage and become more active in the open science space, and we're looking for feedback from everybody who's attending this workshop. For example, one thing we've identified is VAPs and activities which are really best suited to working with the data center on a data workbench. So Jim had a slide on this, and we're very keen to find out more from the ADC on data workbench to really bring the idea of open compute to bear on working with the translators and value-added products. So finishing up, ARM has been behind some of the most impactful open data sets out there. And again, I raised the example of RSchool, Merge Sounding, and some of our very popular open data sets there. We recognize there's a growing demand for open source tools, especially as our value-added products become more configurable. Folks want to actually see our working and work with some of the code we've used to put together some of these data sets. Unless there's a very strong reason, the programming language of the group will be Python going forward. We'll be choosing key VAPs for an open transition. A known candidate underway is RSchool for its being made open and cloud designation technique. And as I said before, feedback is always welcome. And speaking personally here, being an open scientist has led to great success for me. It's led to great success for our group, because for every FTE of effort we've given in making things open, we've been paid back in multiple in the amount of knowledge that's flowing back into infrastructure from those open source efforts. So with that, I will stop sharing and ask, are there any questions?
So Scott, there was one question here that Lexi had. So beyond Python, are certain Python libraries recommended as well, like pandas versus Xray?
That's a really great question. And a little personal anecdote here. When we first started engineering PyArt, it was done about the same time Xray hit the streets. But I'm always worried about technology lock-in, so we didn't really embrace Xray for some time. We took kind of very much of a wait for it and see, but things like Xray and pandas have now reached a level of maturity that we are engaging with them and including them in our code bases. So so the answer there is, at least within my group, we are supporting Xray and pandas as dependencies in our code bases, and with the addition of Max, that we actually actively have folks who are contributors to those code bases as well, because that is kind of a very important thing, is not only working out where the ARM facility can create our own code, but where we can contribute to existing code bases, and that is where kind of ACT really acts as our conduit there as well. So, but yes, determining which code is mature and which ones are not is an expert knowledge area and something we're still working on.
All right, thanks, Scott. You noted that feedback's welcome. How do you prefer to get feedback?
That's a good question, and I will actually pop in the chat. I think we have a contact us link for the translators. Otherwise, I would say Scott Giangrande is a great point of contact there as the lead translator. I will throw his email in the chat. Otherwise, feel free to reach out to me anytime. But I'll see if we have an official contact us link. I imagine we do, and I'm sorry that I don't have that easily on hand.
Krista has her hand raised. So Krista?
Hi, I just wanted to chime in that we also have updated ADI to allow the development of the VAPs to be done with Xray. And we have started using the ACT plotting routines too, and trying to push the VAP plotting toward using ACT.
Yeah.
So
Okay,
Xray is a great tool.
it is.
Mhm. All right. Are there any other questions? I know we're about 15 minutes ahead of schedule here.
Yeah. And I just will point out Karen's comment there in the chat on Xray as well. So, so yeah, kind of as a take home, learn to use Xray because it's going to be kind of the way we do business going forward.
Okay. I see Gary has his hand up.
Yeah, Scott, great presentation. Thank you. A quick question about the use of open source, especially the Python as our default language. So for ARM, as you know, we are celebrating 30 years this month. So we do have quite a few legacy data processes that uses IDL, MATLAB, and other proprietary softwares. Are there any strategy that you are thinking about migrating from those to Python?
That's a really good question, Gary. And this has been discussed in the translator group as the act of doing that translation of legacy code bases into Python has merit. It has merit for a variety of reasons. One, it ensures the compatibility of these code bases going forward. Two, it adds a layer of resiliency because, as we know, one of the common issues we have with MATLAB and Python is licensing issues. A license server goes down and something like that, and we see a flurry of emails. And three, it really adds to that reproducibility aspect of it by translating into Python, ensuring actually really makes us recheck our assumptions as well, make sure it produces the same result. There is value in that, but also by Python is a language that when you follow the culture of the language, it's designed to be readable. And I always kind of subscribe to the philosophy that code should be written for humans and not machines, because that's the way you achieve scientific reproducibility, is making it human readable. So, to kind of sum that up, Gary, there is no official policy yet. It's being actively discussed in the translator group. The activities, and ASCII will be a key area that Scott and his team will be working on this in. But internally, I'm pushing for this because I believe that software is done like the dishes. It's only ever finished if you never intend to use it again.
Okay. Thank you, Scott.
Thanks, Gary. Max.
Yeah, I was just gonna mention that I know that there was that question earlier about some of the Xray versus pandas. Just a shout out to the tutorials going on this week. If you're interested in learning more about Xray, it'll be covered both this afternoon, and then Friday we'll have a little bit deeper dive into Pangeo and Xray. And then kind of along Gary's question, yeah, I mean, I think that's another important point that, especially within the ARM community here, it's important to have that sort of community aspect where people feel comfortable asking questions and asking for help, and a case for having more events like this, especially some of the tutorials and such, really focusing on the educational aspect of helping people transition from some of these quote unquote legacy programs and stuff like that, or some of these previous workflows. So
that's a great point, Max. I will highlight that there will be increased efforts in workforce development going forward. So if there's anybody out there who is kind of like, I can see this open science thing, I can see this Python, Julia, whatever thing, and I'm excited by it, but I need help, we want to hear from you because you're also a fantastic use case for any workforce development work we're going to do. And frankly, if we just preach to the already converted, we're not really making the best use of our time. So we definitely want to build more materials, and Max is taking a lead in this to kind of help folks who see the value in open science but might have some difficulty transitioning.
All right. Any other questions? But if not, just a reminder that this session is being recorded. We will be making all this available online after the workshop is over.
And I'll quickly answer Rich Wagner's question there, because it's a really, really good question. So as folks may or may not know, there's a difference between open source code and community code. Community code is code that is specifically engineered to accept community contributions. And Rich asks, how do you manage contribution to key frameworks like ADI? Is your overall strategy still guided by supported personnel? I can't speak to ADI. I'll leave that one to Krista. But in terms of ACT and PyArt, we have roadmaps. And the roadmaps help us identify areas we know we need to spend ARM FTE to basically make the code base useful and really hit those ARM strategic goals. But they also guide the contributions we'll accept from the community. And this is really important, because for every contribution or new feature we get in something like PyArt or ADI, there's a mortgage to it. We have to support that. People will complain when it breaks. So we actually have clearly defined scopes in the roadmaps for those code bases, and we will not accept contributions that are outside that. We'll encourage those people to start their own code base in ARM Synergy or ARM development and get the kudos for doing that. And that's kind of how we manage that, Rich, is by having really clearly defined roadmaps that kind of help chart the development of these packages.